All right, so chapter 8 in PreCalculus 20 is about systems of equations. And we're going to review that a little bit. These are questions from the chapter test in your textbook. So just selected questions that I think would be really helpful for you to understand so that you know. Some of them are simple, some of them are a little more challenging. But if you can understand this stuff, I think you'd be well positioned to do well on the test. So let's see, number 1. This one I think is pretty easy. It says the graph for a system of equations is shown. In which quadrant or quadrants is there a solution to the system? All right. So we see we have a system. We have a quadratic right here in dark blue, and we have a linear equation in the turquoise here, or the light blue. And so we see one solution, don't we? We see one intersection point. Now, does that mean that there is a solution in this quadrant only? And this would be quadrant 2. Right? Or is there a solution somewhere else? Okay? If you look at this line, all right, we have a certain snapshot of this system, but if this is extended, the way it is, it extends all the way up, and this is extended, which it is, it extends all the way out, then we would have another solution here, wouldn't we? So it looks like we have one solution, but understanding the nature of this, we see that we have solutions in quadrants 1 and 2, looks like. No intersections down here, and no intersections down here, so no solutions down there. Okay? Everybody good with that? You understand that one? Good. Number 2. The system y equals 1/2 x minus 6 all squared plus 2. Now this is a parabola that opens upward. I know that because there's the squared here. Okay, that's a parabola. X is squared. And it's got a positive leading coefficient. So that means it opens upward. And it's actually a little bit flatter, right? It opens a little wider than usual because this number, the a value, is less than 1. Okay, and y equals 2x plus k is the other part of it, and that's a line. Okay, that's a line. And it says that this system has no solution. So that means that this parabola is opening upward, and the line must not intersect the parabola at all. So this is just a rough sketch of what I think this might look like. Got it? So it says here now, how many solutions does the system y equals negative 1/2 x minus 6 squared plus 2 and y equals 2x plus k half? So it's the same line, but watch this. The parabola now opens downward. So it's really the same parabola, but it's opening downward. Now, depending on, I guess it doesn't, it has the same vertex, doesn't it? You see how they have the same vertex? So everything is the same except for the negative part of the a value. So that means the vertex is the same, but now it opens downward. So if there were no solutions before, how many solutions are there now? Yeah, it's intersecting here and here. So it looks like there should be 2. Okay, any questions on that one there? Again, this is thinking outside the box a little bit, right? It's like a little bit more abstract. It's not like, here's 2 equations, give me the answer, solve them, give me the answer. It's making you think a little bit. So if you get that, then you're good. And again, feel free to draw a little diagram with any question that you're given on the test. Draw a little sketch when you can. Pull out any characteristic that you know from these equations, from this system, sketch it out at least roughly, and then some things might fall into place for you. All right, so let's take a look at number 4 on the chapter test here. This one says, what is the solution to the following system of equations? So now we're asking about what is the solution. Now it doesn't say whether we get to use a graphing calculator or do it algebraically, so maybe I'll do it both ways for you. Okay, so if you're given something like this, we see that we have a squared and a squared. So these are 2 parabolas. They both open upward, don't they? Because the a values, this is a plus 1 right here, and this is a plus 1/2. Okay? Now, before we graph or before we do this algebraically, we might be able to answer this question without doing a lot of work if we just use our minds to reason through it. So let's just think. I have no idea. I haven't done this question yet. But if they both open upward, that means we have 2 parabolas that open upward. And let's check the vertices. Okay, so there's a vertex. That's at -2 negative 2. So there's 1, and this one is opening upward. Okay, opening upward, something like this. This one is also opening upward, and it has a vertex of negative 2, 0, doesn't it? So this one, let's put this one in red. Negative 2, 0 is right here. It also opens upward. Now, opening upward, what's the difference between the width of the parabolas, though? This one down here is opening a normal width because it's got an a value of 1. So let's say this blue one represents a normal width. This one that's above it, directly above it, is wider. So it is actually opening quite a bit wider than the original one. So guess what? How many solutions might we have? It appears that if we kind of reason through this, we should have 2 solutions somewhere, right? Because the parabola above this is opening quite a bit wider, so we should have a solution here and a solution over here somewhere. But now, what are those exact numbers? I guess now we're going to have to, well, we could stroke out this one. Looks like it's not going to be that one, right? And so how do we figure out this other one? Well, what about one solution? Kind of looks like we're going to have 2 solutions, so that one's out. X equals negative 4 and x equals positive 2. It could be that one, or it could be this one. So maybe what we could do is we could graph it, or we could plug these numbers in and see if they both work. So you have some options. I'm going to graph this just to refresh our memories on how we graph. So here we go. So if you have a graphing calculator and you want to refresh your memory on how to graph, go to the y equals button, make sure everything is cleared off, and then we're going to we're going to graph these 2 right here. So let's just do that. So I'm going to have a bracket here. It's going to be x plus 2 bracket squared minus 2. It's going to look like this. And we'll hit enter, going on to the next line. This is going to be 0.5 times x plus 2. That's going to be all squared and plus 0, nothing else after that. So I'm going to hit zoom 6 to just put a standard window there, and we should have, oh, look at that. That graph, those graphs, that system looks a lot like the system that we sketched out here. So we have 2 intersection points. Now, if we zoom in a little bit, and here's another shortcut, zoom, you see the zoom in there, option 2, zoom in, option 2, and you can move your cursor over to where you want the center of the screen to be, if you want, and then just hit enter again, and it'll zoom in automatically for you. You don't have to adjust the windows. So it looks like right here, we can kind of see what that intersection point is going to be roughly, and over here it's clearly the 0 one and not the 2. So it looks like negative 1, 2, 3, 4, that appears reasonable for an intersection point or a solution for x. And x equals 0 is also a solution. So this one is D. That one is D. All right? And if you didn't have a graphing calculator, I'll show you how to do this algebraically. Because you need both of these you're looking for the intersection points, let them equal each other. So x plus 2 squared minus 2 equals 1/2 x plus 2 squared. If you let them equal each other and try and solve now for x, you should get your answers as well. So this might take a little bit of time, so let's work through this. We're just going to expand and gather like terms. Okay, so you multiply everything out, and let's start gathering some like terms. So I have 1x squared here. When I gather those 2, I'm going to subtract 4x from the left side. That's going to be plus 4x there. And then plus 4 and plus 4 on both sides, that's gone. So we have x squared plus 4x equals 0. If I factor that, I get this. And then, of course, I have a solution of x equals 0 and x equals negative 4. And that's how you can determine this algebraically as well. Okay? So that's graphically and algebraically for question number 4. Any questions there? No? All right. Okay, on to the next question. A student determines, this is number 6, a student determines that one solution to a system of quadratic equations is 2, 1. What is the value of n if the equations are listed here. Now we've got some missing values here. We've got an m here, an m here, and an n here. Okay, so what's the value of n? Well, let's see here. This is a bit tricky, but because I've got an x value and I've got a y value, if I put the x and the y into the first equation, I only have one variable that's unknown, and that's the m. And I can actually solve for the m then. So that's what I'm going to do. So watch carefully. I'm going to do 4 times x is 2 there. Minus m times y is 1 there. Thank you. Equals 10. So if I plug my x and my y in, I can solve for m pretty easily. So that's going to be 4 times 4 is 16 minus m equals 10. Subtract 16 from both sides, minus 6. Looks like m equals 6 there. Okay. So now now that I know m equals 6, now I can focus on the other equation and look at, I have my m, I have my x, I have my y, and now I can just solve for n. So this might take a little bit of thinking there, but you can kind of piece together. You see, what I've done is I've solved for m in one equation, and then I'm taking that m and I'm putting it into the other equation and solving for the unknown part, another unknown part. So I'm kind of mixing those two equations, so all this is valid. So if I plug in all my values, so I have 6 now times x is 2 squared plus n, I don't know what that is, but I know that y is 1. So see, now I only have one unknown variable, and I can solve for that. So 6 times 4 is 24. Subtract 24 from both sides, I get negative 4. So for number 6, n should be equal to negative 4. And that's a question that's a little bit outside the box, right? You haven't had maybe questions like that with these unknown variables. But again, if you look through that, study that, take what you're given, try and find something that's unknown first, anything, and then work from there. Now that you have a piece of it, try and put all the pieces together to try and solve what's. So sometimes it's multiple steps. Okay. Any questions about this one? I know you've seen it for the first time here. You might not have questions here right now, but anybody have any questions about this one? Okay. All right. So that's number 6. I've got, let's see, I've got 2 more. Okay. I've got 2 more for this review here. So let's take a look at number 10. This one is, and I know you had a question like this before because I've helped with some of you on one like this. Determine a system of quadratic equations for the function shown. So now, instead of sketching the graphs from the functions that are given, now what we're doing is creating the functions from the sketches that are given. And then you're asked to solve algebraically. So what we need to do is identify the equations for the parabolas. This blue parabola, I'll do the first one in blue. I'll make this f of x. Whoops, f of x. And it looks like the vertex is 0, 0. So for f of x, the vertex is 0, 0. That's important. I also have 2 known points here, and this is 3, 3. So I also have 3, 3, and negative 3, negative 3 that are on the parabola. So that's all I need to generate an equation for this parabola. And so I'm going to do this. F of x, do you remember the vertex graphing form? Vertex form? A times x minus p all squared plus q. If you don't have that on your study sheet, you might want to put that on there and study that. Okay? But I have my vertex, that's p and q, and I also have at least one point, that's y and x. And so I need to solve for a, and that's my final piece for this equation. So watch. The y value, I'm going to pick this point. The y value is 3. The a value I don't know. The x value is 3. The p value of the vertex is 0. And the q value here for the vertex is also 0. So now I can solve for a. This is going to be 9. 3 squared is 9 times a. So a is going to be, looks like 1/3. Okay? So f of x equals 1/3 x minus, well, that's 0 squared plus 0. Or f of x equals 1/3 x squared. All right? That's equation number 1. Equation number 2, in the lighter blue, turquoise, I'll try and do lighter blue up here, and I'll move maybe some of this down a bit so we can, come on, let's move that down there, okay. Move that 0 over there, okay. So the lighter blue, a little bit different, but you know what, we'll do it the exact same way. We're given the vertex, and we're given 2 other points that are on there. And you could solve for a the very same way. So let's make this one g of x, okay? So g of x is a times x. Oh, here's my vertex. Okay, so I have a vertex is 1, 0. So x minus 1 plus 0. So that's what I have so far. And I need to solve for a. I don't know if you remember this, but you can have an idea of what a might be, because from the vertex, do you remember when you go from the vertex, if you go over 1 unit and then up to the graph, that value that you go up to meet the graph is actually the a value. That's always the a value. So in this case, it looks like a value is going to be roughly 1/2, doesn't it? Look at this blue graph. We went over 1 and up 1/3. That's exactly where we meet the graph there. See from the previous one? So this one, the a value is over 1 and up a. It's always over 1 and up a. So this looks to be about 1/2. Is that good enough to go on? Probably not. You're probably going to have to prove that. So that's what we'll do here. We'll pick a point and we'll solve for a. But I know this point is on the graph. What is this? 3, 2. So 2 is my y value. I don't know a. X is 3 minus 1 squared. So let's see. 2 equals a times 2 squared, which is 4. Divide both sides by 4. A equals 2 over 4. A equals 1/2. Look at that. It matches up perfectly. 1/2 and a is 1/2. So now you can finish off. And again, this is from earlier in the course. I think we did this, right? We've done this before, maybe a long time ago. But g of x now is this. 1/2 times x minus 1 squared. And you don't have to put the plus 0. So it appears that here are our 2 graphs. I'll just double check. Yep, that is exactly true. So here is the blue graph, light blue graph, and here's the dark blue graph, okay? So let's see here. That one's for number 10. So identify, it also says determine the solutions. I guess we're not quite done yet. So let's do that. Determine the solutions algebraically. Well, again, we want to know where those 2 graphs, where the y values are the exact same. Wherever the y values are the exact same, that's where the solution is going to be, the intersection point. So this is a y value, that's a y value. So let's let this equal this. And that's the easiest way to do things sometimes. So if I have 1/3 x squared equals 1/2 x minus 1 all squared, I'm going to try now and solve for x. Okay? At this point, you want to think back to being smart algebraically, and let's just get rid of these fractions. I like to get rid of these fractions. So you know what? If I multiply everything by 6, that's the common multiple, the lowest common multiple between 3 and 2, I'm going to get rid of those fractions. So watch this. 6 times 1/3 x squared is what? What's 6 over 3? That's 2. 2x squared. I got rid of my fraction. Done. What's 6 times 1/2? That's 3. Okay? So this 6 multiplies by this one or this one. It doesn't matter which one when they're multiplied. You just pick one. So 6 times 1/2 is 3. So that might make things a little bit easier for you. So let's continue to solve here. This is 3 times. If I multiply this out, that's going to be x squared minus 2x plus 1. All right, so from here, then, if I've done all my math correctly, I don't know if anyone has spotted any errors, But you can try and factor this if you want. Two numbers that multiply to 3, that gets us negative 6. That's going to be a bit tough. There's no integers maybe that do that. So let's go to the quadratic formula. X equals negative b plus or minus root b squared minus 4ac all over 2a. Remember that one? So we'll plug those values in and see what we get there. So x is going to be equal to negative 6, so that's plus 6, plus or minus the square root of negative 6 squared minus 4 times a is 1 times c is 3 all over 2 times a, which is 1. So let's see what we have here. 6 plus or minus. Can we do all this in our head? I'm not really sure, can we? That's going to be 36 minus 12, right, is 24. So that's root 24. That's going to be an irrational number. So there's no integers that, solve this. It's going to be something irrational. So if we evaluate this now, and if we write it as kind of rough decimal, we could do that. So 6, let's do the plus first, plus root 24 equals divided by 2. So that's 5.45. Looks like we have for one solution. And then 6 minus root 24 divided by 2 is 0.55. 0.55. Okay? And so, those are the x values for our solution. Now notice, here's one solution, but off the chart here, there's going to be another intersection point way up there. You guys see that? Another intersection point way up there. So that's where we get the second one of 5.45. So those are your x values. However, we do have y values as well, because you remember our equations were y equals this and y equals this. So we should probably solve for the y values as well. And so you just plug each x value into one of the equations, and you get the partner y value. Then plug this one into one of the equations, get the partner y value. And just for the sake of time, your answers then should be 5.45 and 9.90, or approximately that. That's one intersection point solution. And then 0.55 and 0.10. So those would be the coordinates for the solutions for that intersection. So again, if your system has y and x in there, you should give the coordinates y and x for the solutions. Okay, that was a long one, wasn't it? Any questions there? That was a long one. Okay. All right, I do have one more. And again, this is another just out of the box one. Really out of the box one. So no, I'll just do it. I was going to let you guys kind of take a crack at it. Well, I might do that. I'm just going to pause here. If you guys want to take a crack at this one, this would be kind of on the more challenging end of it, maybe. So if you want to take a crack at that, I'm going to give you 5 minutes to work on this, and then I'll come back and I'll show you what this one looks like. So if you're working on number 12, if you're having any trouble at all, I'll just give you a quick update here. You need to find, so what we're doing here is we're finding the intersection of the parabola and the line, and it makes this triangle, right? A up here to C, and then down here to B, that triangle right here. And the question is, determine the approximate area of triangle ABC. So the area of a triangle is 1/2 the base length times the height. So what you're going to do is you're going to find the intersection point here at A, and you're going to find the, the x-intercept over here at B, and you're going to determine this length. So this is the length of the B, the base. And then the height is going to be the distance from the x-axis to C here, which is actually the y value of this intersection point. Okay, so let me zoom in, because now I've made a mess of this here. But let me erase this. So again, this triangle here, A, B, C, that triangle, this intersection point to this x-intercept, that length, is the base of the triangle. The height is the y value of both this line and this parabola at the intersection point. So you have 1/2 the base times the height. So you need to find this intersection point, this x-intercept, and this intersection point. With those values, you can then find the area of the triangle. So I'll let you keep working on that for a few minutes, and then I'll work it through. All right, for number 12, so what you have to do is you have to find these intersection points and the intercepts, and then you can piece those together to find the area of the triangle. So let's do that. So second function, calculate, gives you the intersect, all right? And there's only 2 curves on here, so enter, enter. Let's find this intercept first. So that's going to be x equals negative 3.53. So let's write that down. Negative 3.53. That's going to be this x value here. Let's find the intersection point between, well, the 2 graphs over here. And that's going to be a y value that we're interested in, 14.29. 14.29, that's the height here of the triangle. And then the intersection point over here, that's going to be the intercept. So let's find the 0. 2 finds the 0. Left bound, yes. Right bound, yes. Enter. So you might remember doing this, finding the intercepts. And that 0 is 7.52. 7.52. Okay? Okay, so we have this point here. I suppose A and B, okay. And we have this height and we have this B here. So we're good to go. We need to find the area here of this triangle. So 1/2 base times height. So the area of the triangle is 1/2. The base is 7.52 minus a negative 3.53. That's going to be the base from here to here, that distance. And then times the height of 14.29. So the area of that triangle, we just evaluate that on our calculator. Whoops. So 0.5, oops, let's get out of here. 0.5 times, that's 7.52. That's going to be plus, really, 3.53. Should have some brackets in there. Times 14.29, and hopefully this should give us the answer there for that one. I have no idea what the, oh yeah. Well, yeah, 78.9 or 79 square units. That's great. Okay, so 79 units squared. Okay, so that was a tough one. That was a challenging one, right? But that's how that one pans out. Any questions there? Number 12? Okay, so that's a very detailed review. If you guys can understand those questions, you'll be in really good shape for the test. There'll be lots of questions that are more basic than this one, than these ones. So don't be too worried if you're like, wow, all of those seemed really tough to me. If that's the case, you know what? Just make sure you go over your homework, do some extra questions. But there will be lots more questions on the test that will be a little more basic than this as well. Okay? Questions?